Next example. Now we're starting with the graph and we want to create the equation. So I'm just going to go through and list everything just like before, basically the same order. Technically, I'm going to modify it when I start assembling the equation, and you don't really need to explicitly do the domain for this one. Clearly, we can see the difference in things. So I'm just going to, same thing, start with the x-intercept. Big old dot right there, write it down. There's a hole, write it down. Vertical asymptotes, not all the time do you get, that's kind of a convoluted sentence, you don't always get the dashed line every single time. So I need to look at a specific individual x value and see how the graph is vertical on the left and vertical on the right. Like that. Sometimes it's more than others. The x equals 2, I think both sides of the graph are a lot more vertical than the x equals -6, but it can't be anything else, right? Like that. And if it crosses, if it were at, y equals 10 billion suddenly then it's not a function. So it has to be vertical asymptotes there. All right, y-intercept also marked, write it down. Horizontal or slant, like before, not marked with a dashed line, and there should be an obvious looking break in the range, and whether or not these do not look very horizontal, there's a horizontal asymptote, or it's a slant, which is even more obvious. Like that. And it has to be the same on the left and right. You can't look at the left one and go, oh, that's 3, and on the right, that's 1.5. No, that's not how these work. They have to be the same value. So what value in between? Y equals 2. Like that. All righty. So let's assemble the equation. So there's our data that we collected, and I'm going to go down the list. I'm going to modify the order just a little bit. X-intercepts, they came from the numerator. So let's put that factor in the numerator. The whole, numerator and denominator. So there's a factor in both. Vertical asymptotes, factors in the denominator. Boom, like that. And now I'm going to skip to the thinking about the horizontal or possibly slant. Slant's more complicated, but the horizontal asymptote, in order for it to be y equals 2, that's going to come from the leading coefficients. The degree has to be the same numerator denominator. Are the degrees the same? No, they're not. We only put 2 factors in the numerator and 3 factors in the denominator. The equation we have right now has a horizontal asymptote, y equals 0. So we have to account for that. Can you think of how we might want to account for that? We did it in an earlier example. Square the factor where the hole is, like that. And the horizontal asymptote, y equals 2, is just the leading coefficient out front there. Now, we did not deal with the y-intercept, and we didn't pay attention to the y coordinate of the hole. I like to save those as a double checking. Now, if you accounted for the squaring of that factor, it should be perfect. It's very simple, but I'm going to plug in, double check with the y-intercept in the hole. If I plug a 0 in, I get a 2. So y-intercept, good. When we evaluate to find the hole, you have to use the simplified version. So that x plus 6 needs to get canceled, numerator, denominator. There's an x, the x minus 6, sorry. There's one left over in the numerator, which causes us to get y equals 0. So that Rx at the top there is the correct answer. And we're good to go to the next example.